Hello everybody, my name is Anamaria Crisan and I am a PhD student in the Department of Computer Science. I'm also a Vanier Canada Scholar and a UBC Public Scholar. And today I want to tell you to look at your data. And I want to talk more about the future of data science and data visualization. Now you've heard a lot about data science, but what is it? Data science is taking an interesting domain problem, like something in finance, climate change, or healthcare. I work quite a bit in healthcare, and using methods from computer science and statistics to process, visualize, model, and analyze your data. Now usually we have some interesting problem that we want to work on, or we will in the future, and we apply our fancy data science methods to it. And once we get to the end of this process, we generally want to tell the public what we did and how it's important to them. But this can actually be really complicated. All of this data can be really overwhelming, especially if it's new to people, and they might not know how to process it or how they should actually use it in their day-to-day thinking and how it should affect their decision making. Now this is a great place for data visualization in the data science process, but where it usually happens is at the very end. Once you want to inform the public, we might come up with the data visualization. It could be just an infographic, and we might try several of them until we find one that works, or maybe we just give up and move on. Now, although this is the common paradigm, I think it actually needs to change. There is actually a role for data visualization much earlier in data science processes, and this is when we're getting our data and trying to actually understand it and see what is inside of it. Not just at the very end when we're trying to communicate what we found. This is my favorite example. It comes from Autodesk research. Now, all of those little changing points show different distributions of data, and if we were just to use statistical methods, we would get the same answers, even though everything looks very different. So if you're not looking at your data, you might actually miss the dinosaurs that are hidden in there. Now, my PhD research has been about building the next generation of data visualization tools for data science. This isn't just about communicating data. It's actually more about helping data scientists and other experts understand their data and find those dinosaurs that could be hidden in there. Now, my PhD work takes 3 different steps. First, it tries to discover and understand what people actually need. Then it designs and builds software tools that help with data visualization and data science processes. And finally, I deploy them out in the real world, where I collect a combination of qualitative and quantitative data to assess impact. Now, what do I mean by understanding people's needs? I don't just ask them what kind of software they want. Henry Ford said if I asked people what they wanted, they'd just ask for a faster horse. I try to understand how people use data, how they analyze it, and how we could improve these processes through visualization. Here are 3 examples. Each of these data visualizations show an outbreak of an infectious disease in a hospital. They look very different. They show different kinds of data, and they emphasize different things. Is one more correct than the other? Sometimes when there is a lot of data, people also resort to very complicated data visualizations. Is this necessary? Is this right? Trying to understand the relationship between data and how people use it helps us understand how we can build better data visualization tools as well as different data science processes. So we can take all this information of understanding people's needs, data, and what they do with data and use that into the design and development of better data visualization tools. Now, in my particular work, I'm actually interested in using data visualization to build a bridge between the statistical patterns that algorithms are really great at finding when they analyze data, and the visual patterns, as well as the innate knowledge that people have within them when they are working with data. And of course, there's also the collaborative nature in this as well, transmitting information between humans and machines. This is one project I worked on. Here we were trying to understand how we communicate complex and new data in clinical settings. It's not all just programming. We actually had this fun interactive session where we built prototypes using hands-on methods. and we actually deployed the report and tested it in real clinical settings. I also tried to understand how people are currently visualizing their data, so I could use this information in software processes. The image that you see up there is a summary of all of their different strategies, and if it looks complicated, it's because it is. People have a lot of different ways that they try to understand new and complicated data. Now, one way that I'm trying to help them is actually to build data visualization tools that uses computer knowledge to automatically suggest data visualizations. So instead of a person trying to think about how I should visualize this data, the computer comes up with suggestions for them, and they might engage in a dialogue with the computer to accept or reject the suggestions. Now, the final step of my PhD work is actually trying to assess the impact of all of these tools on the groups of people that they're being deployed to. So I actually take the systems I've built, try them out with people and their data, take their feedback, and refine upon it to create better and better tools. Now, this work is important. As we collect more and more data, we're going to rely on intelligent systems like artificial intelligence to work together with people and data to make sense of things for decision making. But I think it's really important to actually decide what we want that relationship to look like in the future. And for me, this is quite a literal question. I really want to use data visualization as a bridge between people and their data, so that we can find the dinosaurs that might be hidden there that we currently cannot see. Thank you.